Alright, let's find the equation of the tangent and normal line at a point. We're given the function f of x equals x squared plus 2 and the point x equals 1. Let's start with the point-slope formula. The basic line formula is y minus y1 equals m times x minus x1. Then we find the point on the curve. Plug in x equals 1 into f of x. F of 1 equals 1 squared plus 2. That's 3. So our point is 1, 3. Next, we find the slope using the limit. The slope of the tangent line at x1 is the derivative of the function at that point. In these examples, we're using the limit definition to find the derivative. Later on, when we learn derivative rules, we won't need to go through this whole process. F prime of x equals the limit as h goes to 0 of f of x plus h minus f of x over h. When we expand and simplify, the slope becomes 2x plus h. As h goes to 0, it's just 2x. At x equals 1, that gives us m equals 2. For the normal line, we take the negative reciprocal. M sub n equals negative 1 over 2. Finally, we write the equations of the lines. For the tangent line, y minus 3 equals 2 times x minus 1. That simplifies to y equals 2x plus 1. For the normal line, y minus 3 equals negative 1/2 times x minus 1. That simplifies to y equals negative 1/2 x plus 7 over 2. So, the tangent line has the same slope as the curve at that point, and the normal line is perpendicular to it. That's how you go from a function to the equation of the tangent line. Let's do another example to really lock this in. This time, the function is f of x equals x squared plus 3x minus 1 at x equals 1. And just like before, we're going to find the tangent and normal line at that point. We'll start again with the point-slope formula, same as in the last example. Y minus y1 equals m times x minus x1. Then we find the point on the curve. Plug in x equals 1 into the function. F of 1 equals 1 squared plus 3 times 1 minus 1, which is 3. So our point is 1, 3. Next, we find the slope using the limit definition of the derivative. Same process we used in S2. F prime of x equals the limit as h goes to 0 of f of x plus h minus f of x over h. We expand and simplify, and this time the slope becomes 2x plus 3 plus h. As h goes to 0, it simplifies to 2x plus 3. At x equals 1, that gives us m equals 5. For the normal line, we take the negative reciprocal. M sub n equals negative 1 over 5. Now, let's write the equations of the lines. For the tangent line, y minus 3 equals 5 times x minus 1. That simplifies to y equals 5x minus 2. For the normal line, y minus 3 equals negative 1/5 times x minus 1. That simplifies to y equals negative 1/5 x plus 16 over 5. That's the beauty of this method. Once you understand the process, you can apply it to any function. Let's look at one more example. This time, our function is f of x equals x cubed minus 3x, and we're finding the tangent and normal line at x equals 1. Just like in the previous two examples, we'll start with the point-slope formula. Y minus y1 equals m times x minus x1. Then, we find the point on the curve. Plug in x equals 1 into the function. F of 1 equals 1 cubed minus 3 times 1, which equals negative 2. So the point is 1, negative 2. Now we find the slope using the limit definition. F prime of x equals the limit as h goes to 0 of f of x plus h minus f of x over h. We expand it, simplify it, and it becomes 3x squared minus 3. When we plug in x equals 1, the slope m equals 0. This is where things get interesting. A 0 slope means the tangent line is horizontal, and the normal line will be vertical. Let's write the equations. For the tangent line, y minus negative 2 equals 0 times x minus 1. That simplifies to y equals negative 2. For the normal line, since the slope is undefined, the equation is simply x equals 1. So this example looks a bit different. But notice, we followed the exact same steps as before. The only thing that changed was the slope. This gave us a flat tangent line and a vertical normal line.